Chromatography is a versatile analytical technique used to separate and analyze complex mixtures based on differences in the distribution of components between two phases, a stationary phase and a mobile phase. As the mixture passes through the stationary phase, different components interact differently with the stationary and mobile phases, leading to separation based on various physiochemical properties such as polarity, size, charge, or affinity. Here's how to separate mixtures using different chromatography techniques. Thin layer chromatography, TLC. Principle. TLC involves the separation of components of a mixture based on differences in their affinity for a stationary phase, a thin layer of adsorbent material, and a mobile phase, a solvent. Procedure. A. Spot the mixture onto a thin layer of adsorbent material, e.g., silica gel or alumina, on a TLC plate. B. Place the TLC plate in a developing chamber containing a solvent, the mobile phase. C. Allow the solvent to migrate up the TLC plate via capillary action, carrying the components of the mixture with it. D. Visualize the separated components by exposing the TLC plate to ultraviolet, UV, light or by staining with a suitable reagent. E. Calculate the retention factor, RF, values to characterize the separation of components. Gas chromatography, GC. Principle. GC separates components of a mixture based on differences in their distribution between a stationary phase, a high boiling liquid or solid coated on a column, and a mobile phase, an inert gas. Procedure. A. Inject the sample mixture into the GC column using a syringe. B. Heat the GC column to a specific temperature, allowing the components of the mixture to vaporize and move through the column. C. As the components travel through the column, they interact with the stationary phase, leading to separation based on differences in volatility and polarity. D. Detect and quantify the separated components using a detector, e.g., flame ionization detector or mass spectrometer. E. Analyze the chromatogram to identify and quantify the components of the mixture. High-performance liquid chromatography, HPLC. Principle. HPLC separates components of a mixture based on differences in their interaction with a stationary phase, packed in a column, and a mobile phase, a solvent. Procedure. A. Inject the sample mixture into the HPLC column. B. Pump the mobile phase, usually a solvent or a mixture of solvents, through the column at high pressure. C. As the mobile phase flows through the column, the components of the mixture interact with the stationary phase, leading to separation based on differences in polarity, size, or affinity. D. Detect and quantify the separated components using a detector, e.g., UV visible detector or mass spectrometer. E. Analyze the chromatogram to identify and quantify the components of the mixture. By using different chromatography techniques, you can separate and analyze complex mixtures with high resolution and sensitivity, making chromatography a powerful tool in various fields such as analytical chemistry, biochemistry, pharmaceuticals, and environmental science. Choose the appropriate chromatography technique based on the physiochemical properties of the components of interest and the requirements of your analysis.